All right, so previously we did some graphing and we know there's certain characteristics that we should understand when we're graphing lines. So let's take a look at this example we have here, which says, scientists are measuring a distant planet's temperature. The graph shows the temperature in degrees Celsius versus the height in kilometers above the planet's surface. So the graph and reference is on the right here. And just by looking at it, we should understand a few things. Starting with our x-axis, we see height in kilometers is on the x-axis, and we know that also can be referred to as an input, our independent variable. And then temperature is on the y-axis in degrees Celsius. That can also be referred to as an output. Or our dependent variable. And then by looking at this line segment that we have graphed here, we can see it's going down from left to right. So we know our slope is going to be negative. We can also identify our intercepts, starting with the x-intercept, which is at this point here. That ordered pair is going to be the coordinates 5, 0, or with the units, we can say 5 kilometers and 0 degrees Celsius. Now for our y-intercept, we have our point here, which will be the coordinates 0, 40. If we put our units, we have 0 kilometers, 40 degrees Celsius. Okay, so we should understand these things just by looking at the graph because of what we already know about graphing lines. So now if we take a look at part A, it says, at what height above the planet's surface is the temperature 0 degrees Celsius? And we already know from identifying characteristics of the graph, this is at our x-intercept here, right? The temperature is 0 degrees Celsius at the x-intercept. So we know this is going to be 5 kilometers. That's what the height is above the planet's surface. All right. Now for part B, it says describe how the height and temperature are related. So this is a description based on how our slope is occurring. So think about the slope from left to right, it is going down. So we can describe it as saying, as the height increases, that's our x-axis, the temperature decreases. We have a negative slope, so as the height goes from 0 to 1, or 1 to 2, or 2 to 3, or 3 to 4, or 4 to 5, the temperature is decreasing. All right, here's the second one. We have Deshaun is draining an aquarium. The graph shows the amount of water in liters in the aquarium versus time in minutes. Go ahead and pause the video and try this on your own. I also want you to think about, okay, the characteristics of the graph, and then answer the questions, and we'll do it together. Okay, so we think about our graph here again, time in minutes is on our x-axis, that's our input. Amount of water in liters is on our y-axis, that's our output. We have our y-intercept here at 0,540, or if we use units, we have 0 minutes and 540 liters. For our x-intercept, we have the point 3,0, or if we put our units in, we have 3 minutes and we have 0 liters. Okay, and again, we have a negative slope here. So we think about, okay, what is the amount in the aquarium at 0 minutes? That's sometimes people like to think of the y-intercept as the starting point. So at 0 minutes, we're starting, right? And at that particular time, we can say 540 liters. Part B, describe how the time and amount of water are related. Okay, as time increases, the amount of water decreases. It is going down. All right. Now we're going to use what we know about lines, and now we're going to begin writing our own equations. And there's a general procedure for when we're writing an equation of a line that I'm going to use. One, I'm going to first find the slope. Once I find the slope, then I'm going to find the y-intercept and write the general equation. Okay, so in this particular example, we have write an equation in slope-intercept form for the line with slope 3/5 and y-intercept -2. Okay, so step one, find the slope. Well, we have it, m equals 3/5. So that means in our equation of a line for y equals mx plus b, we have y is equal to 3/5 x plus b. That's what we have so far for this particular example. All right, part two, our y-intercept, we have that. It says it's -2, so b is equal to -2. Perfect. So now I can substitute for b. I have y equals 3/5 x plus -2. Okay, that's a perfectly acceptable equation for a line, except we can simplify the way this is written. Instead of writing the plus negative, we can rewrite this as y equals 3/5 x and just -2. All right, and you will want to do that for Alex because Alex is not going to allow you to put in the plus negative. So you do want to simplify that to be the y equals 3/5 x -2. All right, so now here we go. Here is actually very similar to what we just had. Okay, we're writing the equation of a line given the y-intercept and another point. So I am going to do this two ways. Let's start with what I consider to be the easiest way of doing this, and that's just by using the information on the graph. So first, we're going to find our slope. And I'm going to find the slope by using the graph and counting. All right, so if I start from this point here, this point which is 0, 2. And then I'm going to travel to the second point, which is 2, -6. All right, so if I do that, I'm going to start by going down and then to the right. So if I start up here and I count down 1, 2, 3, 4, 5, 6, 7, 8. I went down 8. So I'm going to put -8 in my numerator. Then I'm going to count to the right. 1, 2. So I went right 2. So that's going to equal -4 over 1, which can also be written as just -4. All right, perfect. So our slope is -4. Secondly, the y-intercept. Well, I can actually read that right off the graph. The y-intercept is 2. All right, so starting with our slope, we have y equals -4x plus b. And then when we put in our y-intercept, we have y is equal to -4x plus 2. And that's it. There is our equation of this line that you see in this graph. So I said that's the easy way to do it. You can just count the slope from the graph and read the y-intercept off the graph if it's possible. Now you can also calculate this. All right, so you can use the equation. Sometimes people forget that it's just very easy to read the y-intercept off the graph. So if you didn't remember to do that, there's an alternative to that. So you still need to find your slope, whether you're using the slope formula or you're counting. In this case, it's just as easy to count. I like that, so I'm going to stick with my slope, which we saw before was -4 because we counted down 8 and right 2. So we got -8 over 2, which reduced to -4 over 1, which was -4. So again, we have the general equation so far, y equals -4x plus b. Now at this point, let's pretend as if you did not remember that you could just say your b value is 2. All right, you need to know then a point from the graph. So earlier we saw this point was 2, -6, and this is 0, 2. Okay, so I'm going to calculate the b value. So I'm going to use the point. I'm going to use the point 2, -6 to calculate our y-intercept, our b value. And I'm going to do that by substituting for x and y. So 2 is x, -6 is y. So I'm plugging that into y equals -4x plus b. So I'm writing -6 for the y equals -4 for the slope from earlier. Our x value is 2 plus b. All right, now I'm going to solve for b. So I simplify, I get -6 equals -4 times 2 is -8 plus b. All right, I'm going to add 8 to each side. So I get 2 equals b. So now you calculated that b was 2. So we can write the equation y equals negative 4x plus 2. All right. You might be wondering, well, why did we have to use the 0.2 comma negative 6? Why couldn't we use the 0.0 comma 2? Well, you can. Okay, what if instead of using doing the first graph, I'm going to use the 0.0 comma 2. So 0 comma 2, I'm going to plug in for x and y again. Right, so remember we had the y equals negative 4x plus b. So for y, I'm putting 2. I have negative 4, and then for x, I put 0 plus b. So this gives me 2 equals 0 plus b, or in other words, b is 2. So notice again, regardless of the point I had picked and used for x and y, when I went to calculate my b value, I still got 2. All right, I can try even a third point. Let's pick a point that, let's see, this point right here. This is 1 comma negative 2. What if I would have used that point? 1 comma negative 2. Right, I'll use that for x and y to try to find my b value. So again, for y, I'm putting negative 2 equals negative 4. Notice our slope value is always negative 4. X, I'm putting 1 and then plus b. So I get negative 2 is equal to negative 4 times 1, that's negative 4 plus b. If I add 4 to each side, oops. Okay, that gives me 2 is equal to negative 4 and plus 4 is 0, b. It does not matter what point you pick on the line. It's going to give you the same b every time. Okay. All right, so this time we're given a little bit different information, but the process is the same. Okay, you're given a line passes through the point negative 9 comma 3. It has a slope of 2/3. Write an equation in slope intercept form for this line. Okay, so again, number 1, find the m value. And we have it. We have m equals 2/3. So far our equation is going to be y equals 2/3 x plus b. All right, secondly, find your b value. Okay, now we could graph this and try to figure out the y-intercept, or we can algebraically calculate it using the point negative 9 comma 3. Let's see. If I have negative 9 comma 3, I know that negative 9 is an x value and 3 is a y value. So I'm going to substitute that into the equation that I have so I can calculate b. So I have 3 equals 2/3 times negative 9 plus b. All right, I know that negative 9 divided by 3 gives me negative 3, and then negative 3 times 2 gives me negative 6. So I have 3 is equal to negative 6 plus b. All right, continue to solve for b by adding 6 to each side. So we have 9 is equal to b. All right, So our general equation then is y equals 2/3 x plus 9. Now, I did say we could have tried to find the y-intercept if we used the graph. Let's do that, and it's just good practice for graphing. So if I want to graph this scenario from the directions, it gave us a point which was -9, 3. So if I plot that, I know here's my x-axis, my y-axis. I'm going to go by 1, so go -9, so that's left 9, and then up 3. Okay, and it said the slope is 2/3. Okay, so that means I'm going up 2 and right 3, up 2 and right 3, up 2 and right 3. And what do you know? There's my y-intercept right here, right? That point is 0 for our x value and 9 for our y value. There's our y-intercept. I'll just abbreviate there. There's our y-intercept. So if you were to graph this line, you should get the same information. Sometimes it's harder to read the y-intercept from the graph, or it's not practical. But in this case, it is. The numbers are easy to read and very practical. So there we go. There's our equation of a line, and it makes sense with our graph. All right, sometimes we're given a graph like the one you see, and we want to write the equation of the line. And you might be tempted to read the y-intercept off the graph. Because it's not a whole number, I wouldn't do it, because it looks like it could be 1.5, but what if it's like 1.6? What if the y-intercept's like 1.7? So it will be okay to count the slope using the graph, but I would not try to identify the y-intercept from the graph. So here we go. We're going to write the equation of this line, starting with finding the slope. Remember from before, you can find your slope using the formula m equals y2 minus y1 over x2 minus x1 if you have 2 points. So let's take a look. The first point here is -2, 5. And the second point here is 4, -5. Okay, so I'm going to use those points. I'm going to call this one x1, y1, this one x2, y2. And I'm going to use the formula to find the slope. You can do it either way, use the graph or use the formula. I'm going to use the formula here. So y2, which is -5, minus y1, which is 5, over x2, which is 4, minus x1, which was -2. So we get basically -5 plus -5. We can think about it that way. And then the denominator, because we have that double negative, that's like saying 4 plus 2. So we get -10 over 6. And we can reduce that to -5/3. There's the slope. So in other words, our equation so far is y equals -5/3 x plus b for the y-intercept. Let's use our graph just to verify our slope. All right, so between these 2 points, I would go down and to the right. So if I go down, I'm going down 10. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Down 10, so that's -10. And then I'm going right 1, 2, 3, 4, 5, 6. So we can see here that's -10 over 6, which is again reducing to negative 5/3. So counting is going to give you the same thing as using this formula here. Okay. Next part, finding the y-intercept. As I said before, I do not recommend you trying to just read it off the graph here because you can't be 100% certain based on the precision of this graph. So we do need to use a point to calculate our y-intercept. So I am going to pick the point -2, 5. I'm going to use that one. Okay, so I'm going to use, I want to use blue. There we go. -2, 5. I'm going to make -2 is the x, 5 is our y. Now let's substitute that into the equation here. Y equals -5/3 x plus b. So we get 5 equals -5/3. X is -2 plus b. All right, let's keep going. So -5/3 times -2 is going to be +10/3 plus b. And on the other side, we have 5. Keep going. So I'm going to subtract 10/3 from each side. All right, so we get, on the left side, we're going to get 5 minus 10/3. And on the right side, that's equal to b. All right, we do need a common denominator for the 5. So I'm going to show some work over here. 5 with the denominator of, if we make this into a fraction, we can say 5/1. But we want a denominator of 3, so I'm going to multiply by 3/3. So we get 15/3. So essentially, I want to do 15/3 minus 10/3, and that gives me 5/3 for our y-intercept. Hence, our equation, y equals -5/3 x plus the y-intercept, 5/3. There is the equation of the graph of that line. All right, you're given 2 points, 3, 1 and -1, 3. Write the equation for the line that passes through these 2 points. Go ahead and pause the video and try this on your own. Then we'll do it together. Okay, so again, you can use the formula for slope to find the slope, or you can use the graph. I'm going to start with the graph, graphing these points, 3, 1. So 3, 1, it's right there. And then -1, 3. So -1, 3 is here. You see, this is really easy to find the slope. I would go down 2 and I would go right 4. Right, down 2, right 4. So -2/4 gives me -1/2. Now, if you use the formula, it's fine too. I'm going to say this is x1, y1, and this is x2, y2. So if I did it that way, let's see, we have 3 minus 1 over -1 minus 3. So we have 2 over -4, which again is -1/2. Either way, you should get the same slope. So we have, so far we have y equals -1/2 x plus b. All right, now we got to get our b value, and trying to read that from the graph. If I draw in this line, I'm probably going to be very inaccurate, but you can see here, it's just, you're going to be guessing at that value. It looks like it might be like 2.5, but it could be something that's not 2.5. So I wouldn't risk it. You need to calculate it. All right, so pick a point. I am going to use the point 3, 1. All right, I'm going to use that point 3, 1. All right, so 3, 1. All right, 3 is x, 1 is y. So we plug in 1 equals -1/2 times 3 plus b. So we get 1 equals -3/2 plus b. I'm going to add 3/2 to each side. All right, so what that gives us is 1 plus 3/2 equals b. Okay, common denominator. So we want a denominator of 2. So 1 is equal to 2/2 plus 3/2. So that's equal to 5/2, which is our b. All right, so if you're not sure how I got that 2/2, remember 1 as a fraction is equal to 1/1. And then with a denominator of 2, you need to multiply by 2/2. Hence, 2/2 is 1. All right, so our final answer, y equals, our slope was -1/2, x plus 5/2 is our y-intercept. So there is the equation of that line.